Hello, I'm Sri from CPTU. CPTU presents a course on Python language, section modules and packages. Agenda for this session. Know about Python modules, the dir function, executing modules as scripts, the module search path, compiled Python files for better performance, packaging modules for grouping and standardization. A module is a file with py extension containing Python definitions and statements that can be used as a script or in interactive mode of the Python interpreter. Definitions from a module can be imported into other modules or into the main module. Modules are reusable and organize better management of code blocks. When you quit the Python interpreter, the definitions you have made, the functions, the variables are lost. If you write the same statements in a text editor and save it as a Python file for reuse anytime. The code that is written in Python file is called a script, Python script. To call a module, we need a path. This script path must be available to the Python interpreter. Preferably keep it in the same folder from where you're launching Python interpreter. Let us enter Python interpreter. If I say a string is hello1, str1 prints the string. If I say x is 5, x prints the output. If I exit the interpreter, Ctrl Z is used for exiting Python interpreter and come back. If I say str1, it doesn't output. It says str1 is not defined. Its definition is lost. X the same way. You can enter the same statements in a text editor, save them as a file with .py extension. This is the statement that we are printing. This is the print statement and we saved this as a file mod_str.py in the code folder. Let us save this and call this exit Python interpreter. It has printed the output. This is executing modules as scripts. This is the modularity and the code can be reused. Let us see another example. This is writing Fibonacci series up to n. N is the integer argument for both functions. We have two functions fib1 and fib2 defined here, taking integer argument. This module writes Fibonacci series up to n. In Fibonacci series, the next number is sum of the previous two numbers. The output from the both functions is same. In the first one, we are defining two variables, and with the while loop, we are printing the output, checking this condition. And in the second one, we defined a list and populating it with append command and returning the list. Let us try. Enter Python shell, import. This import command imports everything from the modfib. Let us see the dir first. These are the default attributes that are here. Let us import. Let us see the dir. It has loaded this module. So let us see dir modfib. Then it has these two fib1 and fib2 here. Let us call fib1. So without argument it gives error. It requires an argument. Let us say 20. Then this is the Fibonacci series. Let us call fib2. This is a list. You see the square brackets here. Let us see the dir of fib1. These are the attributes for this function. We have seen executing modules as scripts. Python comes with a library of standard modules called as Python Library Reference. Python standard libraries provide tools suited to many tasks and functionalities. The rich features and functionality of Python is based on these extensive standard libraries. The Python Package Index, PyP, is the official repository for third-party Python software. PyP collection is growing in addition to the standard libraries. These are Python standard libraries. Please watch a session on Python standard libraries for more information. This is writing Python code from the Python interpreter. The code will be lost once you exit the interpreter. Write the same code in a file and save it with .py extension. This file is called module. Module comprises statements and functions that we define. We can call the module to use its features and can be edited easily. The most useful tool is the built-in function dir. This is used to find out which names a module defines. It returns a sorted list of strings. It lists all types of names, variables, modules, functions, etc. Let us exit the interpreter. Enter again. Without arguments, dir lists the names that you have defined currently. These are the names it's showing. From the previous example, let us import modfib. Let us see the dir again. It has loaded this modfib into the current namespace. We can see the details of modfib with dir. It shows the attributes and the functions defined in this module. dir doesn't list the names of built-in functions and variables. If we want to see the built-ins module, then we need to import it. Let us try dir built-ins. The error message says built-ins is not defined. Let us import built-ins. Now try dir built-ins. It displays all the built-in functions. It has got range, round, string, tuple, and all this. If you want to see the details about sys, it will not show. We need to import to see its details. These are always available for us to use without importing. So the built-ins, this is Python installation path. Python caches the compiled version of each module in the PyCache directory under the name module.version.pyc. This will speed up loading modules. As an example, compiled version of fun123.py would be cached as pycache/fun123.cpython-37. This is version of the python.pyc. These are all the Python scripts, and we have PyCache folder. These are all compiled Python files. Let us see the contents. This is all compiled bytecode, compiled Python code, which helps in faster processing. Python checks the modification date of source against compiled version to see if it's out of date and needs to be recompiled. This is completely automatic process, and also the compiled modules are platform independent. So the same library can be shared among systems with different architectures. It's preferred to keep compiled module in the same source directory. You can use the O and O switches on Python command to reduce the size of compiled module. This is optimization. -o switch removes assert statements, and -o switch removes both assert statements and doc strings. Doc strings is a help text, and generally for the large programs, this optimization is used. Python compiled files are loaded faster compared to the .py files. Compile all module can create .pyc files for all the modules in a directory. pep3147 details more about this process. This is path for the pyc files. When you are importing module, it checks for the .py file. If it is found, it will check for the matching pyc file. If it is found, then load the pyc file. Matching pyc file is not found, then it will check whether it exists. If yes, it compiles pyc file from py file and writes to pycache pyc. This is a module loading process from pep3147. dir function we have seen. It returns a sorted list of defined names and strings in Python's current local system table.